Coming up on This Week in Radio Tech, Jeff Welton of Nautel is our guest, and Chris Tobin joins us also. We're talking about some pretty interesting things, including safety and security of your IT-connected stuff, your internet-connected equipment, how to make that actually, be safer, and why you really need to. Plus, what about the idea of using single-frequency network technologies with your HD signals? It works, and it works really, really well. Jeff Welton will be talking to us about that, plus an update on a 2-megawatt AM transmitter on This Week in Radio Tech. TWiRT is brought to you by the Telos Alliance and the new Omnia Volt audio processor. More processing power in 1 RU than others give you in 3. By BSW, Broadcast Supply Worldwide, where Let's May a Deal is on. And by Lavo and the new Ruby Visual Radio Console. Ruby is a new kind of console for a new radio environment. Hey, welcome into This Week in Radio Tech, the show where we talk about everything from the microphone to the light bulb at the top of the tower. And this week, we're going to talk about the transmitter and a few other things as well with Jeff Welton, our guest. Hey, welcome in. I'm Kirk Harnack, your host. It's Thursday, the 4th of May. May the 4th be with you, right? For Star Wars fans. Our show, This Week in Radio Tech, brought to you by some great sponsors, the folks at the Telos Alliance, also BSW, Broadcast Supply Worldwide at bswusa.com, and by the folks at Lavo with the new Ruby console. We'll be talking about all those in just a few minutes. Chris Tobin is nearby. He's not here yet. He should be coming in sometime during the show. But for now, let's bring in our guest. That is Jeff Welton from are you in Halifax?
I'm in Chester, so I'm near Halifax, about half an hour away.
All right. What's the weather like? It's raining and kind of warm here. What you got there?
I'm sorry. It's sunny and in the mid 60s. We were running around in the t-shirts doing yard work earlier today. It's a terrible thing to happen or live through.
You guys wear t-shirts in the mid 60s, don't you? We don't do that in the South.
We wear t-shirts when it's 45. I mean, when you've got snow on the ground 6 months of the year, you celebrate whatever warmth you can get.
Oh, wow. Hey, by the way, you and I, this is the first podcast that we've done with a new technology. We have used Skype for years and years, and it's the best and it's the worst at the same time. And thank goodness for Skype, and also we love to curse it because of all the strange things they do to it. But we're using a new technology. It is called vMix Call, or vMix, and the website is vMix Call. And so that's how we're talking. Apparently, it's making things easier for Suncast, our producer. He seems to like it. And what I like about it is usually with Skype, my return video showing me the show is just awful. It's horribly, it looks worse than real video from 1993. It's just awful. But this, it's full, it looks really good. Barely pixelated at all. I can see what's going on, and I really appreciate that. So, Jeff, how does it look for you? Was it reasonably easy to connect and use?
It was about as simple could get. You press the button, enter the password, and I get to look at me. And usually I show slideshows, so I don't have to look at me, but I guess I'll have to make do tonight.
Oh, gosh. All right, well, we're going to try this out. Hopefully it won't bomb out. It'll be just great. So, Suncast, thanks for turning us on to this technology, and we'll have to keep Skype in the back pocket in case a guest can't connect to using this. It does require a Chrome browser, and it's using this technology called WebRTC. It's a protocol framework that helps computers get media in and out of them live. So anyway, it's the experiment. It's the first time. I noticed there's a chat bar over on the right-hand side here. Jeff, do you have that chat bar as well on your monitor?
If you look in there, or maybe you hadn't logged in yet. I already had to edit something to the chat, just indicating that the dog had been duly threatened as she kicked up too much fuss where I'm at home.
Okay. Well, I'm not sure if that chat's for everybody or just who it goes to, but you didn't see me type some gibberish, did you?
I haven't really been paying attention to it. I got to shut off at the moment.
Okay, good. All right. Well, we'll move on. Hey, we're going to talk about some cool things. The NAB show just finished up. Last week, Chris Tobin and I and a bunch of guests all broadcast live from the NAB show, the final hour or final 2 hours or so that it was going on. And part of the NAB show is the Broadcast Engineering and IT Conference. It used to be called the BEC, the Broadcast Engineering Conference, but they added IT to it. And we've been talking about that for years here. It's pretty important. So Nautel was responsible for at least a couple of white papers. And I love white papers because a white paper gives an engineer or someone with something to say of interest to other engineers a chance to do so in the form of a well-researched paper, well-outlined. They don't accept junk. You've got to have your ducks in a row. In fact, we submitted a couple of papers that I wrote or co-wrote, and they came back with red marks. So we knew that, oh man, we got to have all of our facts straight, and no nouns and verbs misplaced or mismatched. And so it's a great chance. White papers are a great chance for engineers like me and you to learn what other people who think about some of these things all the time are talking about. We're also going to have an update on a 2 megawatt AM station transmitter in Hungary, and Jeff's going to tell us about hands-on, a 400 kilowatt AM transmitter. Pretty interesting. Plus, a little section on at the end of the show about the tools you need to have on hand and the mindset that you should have when having to fix a product. And we'll get more on that in just a few minutes. Hey, our show This Week in Radio Tech is brought to you by my friends at the TELUS Alliance. And the TELUS Alliance won some awards this year. One of the things that they won an award for was the new Omnia Volt. Maybe Suncast has a picture of that. He can pop up there. I don't know if he's got that or not. But the Omnia Volt is a brand new processor, an FM or AM or studio processor or HD processor from the engineers at Omnia. And people ask me, okay, see, you can see right there. It's if you're watching the show, it's 1 rack unit tall, and it's got a lot of meters on it, white and red LEDs, a nice big red knob on the side, and an LCD screen. People ask me, what's new about this processor? In fact, it looks a little bit like the older Omnia 1. How is the Omnia Volt different? Well, the easiest way to put that is the Omnia 1 was designed before the Omnia 11 came out. The top of the line, thoroughbred, absolute premier processor from Omnia, the Omnia 11. But the Omnia Volt was designed after the Omnia 11 was designed. Now, we can't tell you all the special sauce, the secret ingredients inside the Omnia Volt. But I can tell you that Cornelius Gould, the chief algorithm engineer at Omnia, and Frank Foti both had a personal hand in designing the Omnia Volt, as you might expect. One of the things about the Omnia Volt is it's very flexible. You can load into it FM software, AM software, studio software for studio mastering kind of jobs, and also HD software for any kind of bitrate reduced application like streaming or DAB or DRM or HD radio. So those things the Omnia Volt offers, all those things that you can load in, no extra cost. You can download those setups, those modes, absolutely free, load them in. In fact, you can keep one loaded in while another one is playing. So if, let's say you have, like many people do, many engineers do, they have an FM stations and some AM stations, and you want a backup processor, no problem. Get yourself an Omnia Volt and have FM and AM both loaded into it. You can choose whichever one you want just by going to the configuration page and choosing it and rebooting, and it'll be what you want. And away you go. So the thing about the Omnia Volt is it sounds amazing, really amazing. You're going to be impressed for the price, and it's under $3,500. So check it out from your favorite dealers. All of the Omnia dealers are up on this, and they have it available and ready to go. So Omnia, thanks very much for sponsoring This Week in Radio Tech. I got one other quick update for you from the folks at the TELUS Alliance, and that is if you're an Axia user, and there are a lot of you out there. I mean, there's over 7,000 Axia consoles out in the world, and there are probably on the order of close to 20,000 Axia IP audio drivers, maybe closer to 30,000. Well, the new Axia IP audio driver is now AES 67 compliant. So if you want to use audio over IP and you want AES 67, it's built in to the Axia IP audio driver. So is Livewire. Of course, Livewire is still there, and there's more functionality than ever before in the Axia IP audio driver. It's a free upgrade if you already have it, and contact your dealer if you want to buy it. It's the Axia IP audio driver now with AES 67. All right, let's get back to it here. Jeff Welton's with us, and by the way, I just got a message from Chris Tobin, and Chris Tobin's not going to be able to join us just yet. He is stuck on a roof in probably New York City. So we'll see if he can join us a little bit later on. All right, Jeff, let's jump right into it. I talked about the Broadcast Engineering and IT Conference, and there was a paper given on safety and security in an IT environment. Let's talk about that. What was the paper about?
That was me, and it was, I didn't write a paper, I just did a presentation because, well, the week before, 2 weeks before NAB, there's very little time to do anything extra. Primarily, we started looking at the fact that engineers are getting older. John Poiré did a really good paper at the same conference in 2012, talking about the fact that over a 10-year period, the average age of the broadcast engineer has gone up 4 years. Because we're not seeing new people come in as fast as us old guys are starting to retire. And I guess I can call myself an old guy now. I've been with Nautel 27 years, so that almost qualifies. One of the things we're seeing too is that a lot of folks with a lot of IT training are getting in, but not as many folks with radio training and high voltage RF and AC. So there's a lot of risk factors that folks just may not be aware of, and I tried to cover that as much as I could. The other thing was the IT aspect of it is a separate topic, where you're seeing stations frequently getting IP audio codecs hacked and broadcasting things that may or may not be objectionable depending on your leanings. As well as there was a station not too long ago had their RDS hack and broadcasting zombie apocalypse, which, you know, as entertaining as it may be, is probably not the real purpose that they wanted their RDS to be used for. So we were talking quite a bit about, you know, not using default username and password, putting up firewalls, and just generally doing an IT audit of your entire facility, because it's amazing how much stuff connects to the internet these days, including your transmitters.
Wow. Yeah. You know, the easiest thing to take care of seems is passwords. Don't use default usernames and passwords. And admin is such a popular username. So is user. But you don't use that. And then the password, my goodness, there's a bazillion password keeping programs like LastPass and others. Or, you know, if you have to, you know, if I wouldn't recommend using the same password on everything, but you could, as long as it's, you know, it's got some high entropy and it works. You don't want that getting out in the wrong place. But wow.
Well, there's also a security aspect. The one thing I mentioned was that a lot of times, you know, folks, when you have a security system, if you've got a key card system, then when an employee leaves or is terminated, you tend to either change the passcode or change the key code, whatever, but nobody thinks to change the IT passwords. And depending on what they had access to, you know, if you do a quick Shodan search, you'll find 10,000 broadcast devices online unprotected. Most of them, you can look up the default username and password on the manufacturer's website. I mean, I did that as a test with one of our transmitters and got to the point where I could turn it off.
Did you, in your talk, did you talk much about using a VPN to enhance security, as opposed to what many folks do, and I still have done in a few places, is using port forwards to remotely access something? Even if you have a good username and password in there, that's hard to guess. A port forward, you know, can still open things up, especially if the hacker understands the operating system that he's then looking at through the port forward. So what about VPNs?
Absolutely, VPNs are a good system. I mean, nothing is hack-proof as somebody is determined. But the big deal is, if I'm doing a quick scan, I shouldn't even be able to see your device. So, I mean, for example, the radio station that I co-engineer, we use a closed circuit between the transmitter and a laptop, and then use TeamViewer to access the laptop to get to the transmitter. Not foolproof, but again, it doesn't show up on a scan. If you can't see it, you're less likely to try to crack it, unless you already know it's there.
If I had to give some advice to broadcast engineers about what's a skill that they could really put to good use, and that would be learn about VPNs. I know a little bit about them now. I still need some help, and I need to learn some more. But I've got basic VPNs set up for the key players in my own radio stations so that we can access gear across a secure and encrypted tunnel from wherever we are. But that brings up an idea. It's possible to set up VPNs so that they only respond properly, for example, from a known incoming MAC address. And that would be another level of security, and then easy to turn off from somebody else. Because if you give VPN access to a number of employees and then you let one of those employees go, well, that employee still has VPN access, unless you gave them different passwords. So you could certainly base the VPN access on something like a MAC address, and then have a better chance of cutting that employee off.
Well, exactly. I mean, we use a 40 client VPN at the office, and it is specifically tied to the devices it's installed on. So, the devices are company property. If somebody's let go, the device goes with that or stays with the company, and they just don't have access. So offsite, that's we've got things in our network that we don't necessarily want anybody to be able to get into on a regular basis. And I'm sure just about any company would qualify.
One of the cool things about VPNs is once you learn how to set them up, not only for remote access employees to come in, but also VPN between sites, then you have the ability to have one remote access in to a given site. And let's say you've got radio stations, facilities in 3 or 4 different communities. Then you can VPN into one and then automatically you could VPN tunnel into the others as well. Convenience for you, still secure. And if you've got machines, PCs or other machines that need to talk to each other, or let's say that all of your engineering expertise is in town A, but you've got studios in towns B, C, and D, well, it's convenient and still secure for the people in town A to be able to browse to or otherwise deal with equipment that's in those other towns through VPN. And that VPN could be up and running all the time, router to router. So that's another good thing to do instead of opening a lot of ports to things that may have VNC or other port, especially port 80 kind of access, HTTP access appearing there. Yeah.
Yeah, exactly. And I mean, when you get right down to it, a lot of remote interface equipment these days, it is IT accessible, ours, other transmitters, various other things that I can think about. They all use port 80. It's web browser access. So, you can't really block that. But having a VPN tunnel gives you a good way for anybody who's sniffing around not to even see it. And that's what I say. If they can't see it, they're less likely to hack it. They'll choose the low-hanging fruit.
So again, that great skill is learn about VPNs, and I'm saying that for myself too. I know enough to make a couple things work, but that's a skill that I need to work on as well. So I'm really well versed because I need to do these things. I need to have a VPN access router to router to several different sites up all the time and available. So yeah, need to do that. Hey, the other paper was about HD single frequency networks, right?
That was Philip Schmidt's paper. He did write the full paper for it. He actually won the award for best engineering paper at the conference this year with it. We've done a lot of, last year he had done a case study on one that we piloted on the West Coast in California. And he's done an amazing amount of work with it. Picture an on-channel repeater with an overlap area that has no interference zone, something that you just can't accomplish in analog. And he can build a whole network like that. So it's really kind of cool.
Whoa, now I'm having trouble wrapping my brain around that. Tell me what that's like to move or to drive around in an HD SFN or single frequency network. What does the consumer, the listener, hear as they drive between transmitter sites?
They hear the audio, and that's all. There's no overlap. Well, there's no interference. There's no dropouts. As long as you can keep it synchronized to the point that both signals have a bit going high at the same time, even if they're off by a couple of degrees, It makes no difference. Whereas in analog, as you phase shift, as you go around the overlap zone, of course, you create interference. And the only thing you can do is phase rotate it in order to minimize the interference where the primary target audience will be, whether it's on an interstate or a heavily populated area, whatever. With HD, we don't have that. As long as we can get the synchronization. Now, of course, if you go more than the phase angle of the positive peaks away, then you're going to have some interference or a dropout. But typically for the field testing we've done, we've run, I think you had 2 or 3 translators running off a single transmitter, all on the same frequency, all with overlap areas and 0 dropouts.
So if a person driving around was to listen to the analog FM, they would hear the typical things you hear when you have 2 FMs working against each other. You'd have some areas that sound like multipath, right?
That sort of beating against each other, an occasional flanging sort of sound is the way I describe it exactly. So the analog, you've got that. If you've got an HD receiver and it's locked onto the HD, as you transition from one to another, you don't even know. And we ran a demo of it at the show this year, which is really kind of cool because we could turn one transmitter on to simulate you being in that area, and then turn the other one on to simulate the overlap, and then turn the first one off. And we were picking it up off air from a dummy load with a plain HD receiver, regular old, we used a Sony for that one, doesn't matter. And no dropouts whatsoever.
Can you describe basically the technique or technology that would keep all these, the main and translators in perfect sync on the HD?
It's mostly done with GPS, just a 1 PPS signal. There's not much to it. The only big challenge that we found is keeping the audio. Of course, everybody knows about the HD audio delay and how it likes to occasionally walk away a sample or two, or more or less, depending on your configuration. And that was the big thing, keeping the audio perfectly synchronized. And for our test, we used an Innovonics Justin, which is, according to Philip, it's an awesome toy. Awesome enough that we kind of borrowed the one that we had at NAB and took it back home with us. So not to give a plug for Ben at Innovonics, but yeah, that's the big challenge. And right now that seems to be the best way to do it.
Wow. Okay. So give me a typical application. I guess some broadcasters already have a main signal that may or may not, it may be in the city of license, but that may not be the city of financial interest, if you will. And then they may have a translator or 2 or 3 that are closer to or maybe surrounding the city of financial interest. Could this be used in that situation? So people driving around in the big city as well as going out toward the burb where the station's main transmitter has to hit? Is that a good application, or are there some others?
That would work. Single frequency networking is used extensively in Europe. It's something we don't do an awful lot here in North America, and we really could because, number one, it allows you to narrow down or to reduce the hunt for a frequency for a translator if it's an on-channel booster. And I mean, we primarily use them to fill in areas where you've got multipath or terrain shielding from the primary signal. And this gives a way where when you hit an overlap area, you just don't have any objectionable interference. So yeah, they are used. I'll give you one example of an emergency use. Station in Eau Claire, Wisconsin lost a 2,000-foot tower a couple of years ago. You may remember that. We had a radio station on that tower. Actually, we sold a bunch of stuff after the tower came down because it kind of came down on the transmitter building in part. But we put a temporary installation there with a low power transmitter on a temporary antenna at their studio, and they had a 5 kilowatt there into a 2 bay, which didn't cover near as much as the 100 kilowatt on their main at 2,000 feet. So they put a 20 kilowatt fill-in booster in their secondary market on channel, and we synchronized those. Now, that was done in analog. We were fortunate there were only a couple of roads between the 2 areas, and we were able to mostly minimize the interference, but not totally eliminate. And HDSFN would have totally cleaned that right up.
And actually, I misspoke earlier because now I understand better. We're not talking about necessarily stations on different frequencies, a translator on a different frequency. On-channel boosters is where this is. We're not talking about the radio switching frequencies to an AF or alternate frequency. We're talking about
Right.
on-channel boosters here, and they could be on-channel boosters or two stations on on the same frequency. Of course, they wouldn't have they'd be far enough apart to where they normally wouldn't interfere with each other. So that'd be a less likely scenario. But the on-channel booster is a real likely scenario.
Now, one of the ways this could be used potentially, and it comes down to cost versus coverage. It costs you a lot less to put up a Class A than it does to put up a Class C. But if you put up 3 Class A's in a row, all on the same frequency, potentially, depending on site and infrastructure, you could do that for less than the price of a single Class C. Certainly, the power bill would be lower. So if you ran them all HD and networked them, single frequency networked them, so there's no interference in the overlap zone, it'd potentially be an alternative solution in some cases. Or if you've got a really nasty pattern to hit, do it with 2 transmitters instead of 1.
And this sounds like a solution that, from a regulatory point of view, might be more suited right now for use in some other countries. But maybe if this seems popular and seems workable, then the FCC could maybe make room for this kind of thing. Instead of having one Class C, you have several Class A's on that same frequency with the same coverage area, or similar, or more in where you need. But that's a really interesting concept. I suppose this works just fine also in your scenario where you get rid of the FM, the analog signal, and you fill that in with more HDs, like Nautel has already demonstrated, having upwards of 15 different program channels digitally in HD on an FM channel. Yeah.
HD multiplex is what we call it. And yeah, that would work exactly. Yeah. I mean, it give you a prime example. It's sort of like the Eureka 147, the L-band DAB concept, where you have a central pod and then radiating outwards, you have additional pods to fill in the same coverage area. The difference being in this case, of course, what you could do as an example, if you put a central pod up with 15 signals on it, split between 5 or 6 stations, whatever. And as you move out, maybe the Class A on the central pod doesn't get any single frequency network stations, any fill-in boosters. The Class B might get a first ring of them, and the Class C might get the outer ring, something like that. It's sort of one way you could do something like Eureka 147, but maintain the parity with existing license coverage areas. So it's something we throw up as a science project. We build a tool and see if you guys find a use for it.
Yeah, I like that. I like that attitude, and hopefully there's broadcasters who can find that. You introduced some new technology, and look, I have very little experience with actual HD broadcasting. I have a lot of experience with audio processing for HD, but not with the actual RF plumbing and mechanics that it takes. I was actually more up on it at the beginning of HD than I probably am now, because none of my radio stations are HD yet. But Nautel has come out with a single box that is an importer and exporter in the same box. And I need to understand a bit more about how this works. Let's take a brief look at that, and in a few minutes we'll check out another sponsor. And if we need to go into some more detail, we certainly can. But tell me what this importer exporter does.
Okay, we call it HD Multicast Plus, and that's basically all it is: importer exporter in the same box. So the exporter creates the HD signal that drives the XGen in the transmitter, and the importer takes your HD 2, 3, your program associated data, or RDS for HD as I like to call it, and spits that data over to the exporter. So rather than having them as discrete units, we were able to put them in the same package and cut the cost down a lot, which means it gets a whole lot cheaper to implement. I will say right off, it's on a Windows 10 platform. So the reason I bring that up right away is because people go, "Ooh, Windows 10," but it's an Enterprise Edition embedded version with the updates turned off. If we want you to get an update, we'll send it to you, because we're like that. But the reason is that we're finding a lot of our campus clients, university customers, are really getting nervous about the Win 7 platform that we're using at the moment, because of course it's got a sunset date in about 3 years, if I'm not mistaken, for support. And campus IT departments look at this as a computer connected to the internet, which effectively it is. So they want to see current platforms running.
So this importer exporter in a typical HD broadcaster's situation where you've got a studio here and a transmitter site some miles away, does this importer exporter go at the studio? And if so, then what comes out of it and goes to the transmitter site?
Well, it can, or it can go at the transmitter site. My preference is to put it at the studio because flat out it's a computer, and typically studios have more stable power, not always, but typically. So you can put it at either end. Obviously, if you put it at the transmitter site, you're feeding all the audio channels out to the transmitter site, so you need the ability to feed multiple audio channels. If you put it at the studio end, then similar to what we have right now with importers and exporters, the signal out of the exporter going to the transmitter's XGen in the exciter is a fairly low bit rate, less than 2 megabits per second, say. But it's a low bit rate UDP data stream. So you do need a digital STL or some method of getting the data from point A to point B. A lot of folks use those unlicensed Wi-Fi bridges. They work really well. But and that's one of those situations. Now, one of the things we've done with the new one, we developed this thing in 2009 called NRHD. It's Reliable HD Transport. And effectively what it does is takes the bursty HD data stream, which will be a burst of about 1.8 megabits, followed by some near silence, followed by another burst. And we've repackaged that into a low bit rate steady stream that travels, we've passed it over 160 kilobit satellite channels before. So by default, the new Multicast Plus has that installed. So you get that whether you need it or not. And that was a great technology. You guys came out with that some years ago because people were having problems with their HD. The sometimes the bits would all jumble up or bunch up together, and you need to get, like you said, over a megabit and a half through. And sometimes people had a T1, so 1.544 was the limit, and yet the system wanted to put through 1.8. But you guys figured out how to spread those out so it's very consistent and can be carried certainly on T1s or other reasonable bit rate internet pipes. Yeah. Right. Well, like I say, I've done it over 160 kilobit satellite downlink before. So
wow.
It doesn't require near the bandwidth. I don't think I'd want to trust it over a 3G Wi-Fi or 3G internet card just yet. But it at least gives you more options. Again, another tool in the arsenal.
That is cool. Let's continue anything else on that in just a minute. Our show, This Week in Radio Tech, and by the way, you're listening or watching to This Week in Radio Tech, episode 347. Jeff Welton from Nautel. They are not only our friends, they're everybody's friends. They're one of the great companies with consistent innovation and great technical support, and of course, a lot of folks just love their transmitters. Appreciate Jeff taking his time to be with us and tell us about some of the innovations that they've been working on. And we're going to have some stories in a few minutes about 2 megawatt transmitter and hands-on 400 kilowatt. I hope the hands got off before the power, the RF actually all came on. Our show This Week in Radio Tech is brought to you in part by our friends at BSW, Broadcast Supply Worldwide, and their website at bswusa.com. It's May, and that's the month for Let's May a Deal. Get it? Let's May. Okay, fine. Where you can get trade-in rebates on wireless microphones, for example. Give them a call and talk to them about those trade-in rebates. There's also a trade-in rebate on select Orban processors. So they're taking in trades, and they'll sell you an Orban processor. Also, there's the Arrakis ARC Talk Blue radio console with 5 mics, 1 USB, and now with 2 Bluetooth phone channels. So easy to get audio in and out using Bluetooth. That really works. Also, an instant discount on a Tascam DR05 micro SD audio recorder. And that I've used that before. That exact same one works great. They have a headset special. These are the headsets, the Audio-Technica BPHS1 headset. They're offering a 3-pack at a special price. These are the headsets that we used at the NAB show for This Week in Radio Tech, and I loved them. These really, really worked well. They sounded great. The mics worked well. They rejected off-axis noise and noise behind the mic super well. Again, the Audio-Technica BPHS-1 headset, a special price on a 3-pack, and guess what? The connectors are already installed, and they're probably the ones you probably want. XLRs for the mic and 1/4-inch tip ring sleeve for the headsets. More things on sale too. For example, Wheatstone's Aurora X1 audio processor for FMHD, and the Henry Engineering Mic Alert Tally Light controller. This is also on sale. It's $199. Really well built, really gorgeous, and safe and easy to use. You don't want that 110 running on Belden 8451 cable like you may have come across at some old radio station installations. So let's May a deal. Check them out on the website at bswusa.com, or you can give them a call at 800-426-8434. And the last thing to point out is this: when you buy something from bswusa.com, their stocking warehouse is in Ohio, not far from a huge airport. What does that mean? It means you can order into the evening as late as about 7 p.m. Eastern time. And if it's in stock, well, it can ship that night, and you can have it the next day, of course, for shipping charge. But they have set up their business that way so that you can get gear. Maybe you found out this afternoon that you needed something, and bswusa.com is certainly the place to go. They can help you out. Thanks a lot, BSW USA, for sponsoring This Week in Radio Tech. All right, continuing on here. Jeff, any other final thoughts on that importer-exporter Multicast Plus?
The big thing on it is, I mean, the functionality is pretty much the same, except for the addition of NRHD, which it does add several features. Like I said, the lower bit rate, clock packet tunneling, little things that tend to bodge up an HD signal in some cases, especially over a low bandwidth stream. So that's good like that. But the big thing is really the price. It's about half of what we used to need to get for an importer exporter. So wow. It's like I say, we're trying to make it more cost effective.
Half is good. Half is good. It seems that with advances like that, even smaller stations like mine in Mississippi may now have some reasons to go to HD. So many cars now come standard with HD. I forget how many millions of cars are on the road, but it's significant. And frankly, smaller broadcasters like me are looking for perhaps a way to feed separate programming to a translator station. And that can only legally be done, or one way is using an HD2 signal on an FM. So that can be a good way to get the audio you want to a translator, because you're translating the HD2 signal. So cool.
And you'd actually be surprised how many people are actually listening to it. We've had situations where we've just put on a transmitter, turned on HD as just a demo or a test, and the station will get 20 or 30 calls in the next hour or so from folks that are actually running HD receivers that didn't even know it. So, I'll be calling you on Monday.
Okay, talk to you. You know who to talk to. He's in Pongo right now. Yeah. Yeah. All right. I may wait till he gets back from Pongo. Hey, next, I remember, it seems like last year we were hearing about a project that Nautel got, and that was a 2 megawatt AM transmitter in Hungary. Talk to me about that. How's it going?
Last year we won a tender that had been out for a while. It was a pretty good battle, and we won a 2 megawatt, and absolutely it is going to Hungary. It's 5 400 kilowatt transmitters with one giant combiner. As far as how it's going, well, the 400 kilowatt transmitters we had one of them up and running in test room this week. We'll talk about that in a little detail in a couple of minutes. The combiner is pretty much together. The entire system should be shipped and installed before the snow flies here in Canada again. So later on this summer, early fall.
Wow. So that seems an odd combination, 5 times 400 kilowatt transmitters, but yeah, that's what it takes. What a combiner. My goodness. How big is this cabinet that combines and spits out 200 megawatts at one end?
2 megawatts, but it's not tiny by any stretch. It's and keep it in mind, I haven't taken a measuring tape to it, but it's much bigger than 8 by 8. Let's put it that way. The
Okay.
whole
Okay.
system will be, I think the room it goes in is going to be about 30 by 30 with lots of room to walk around because, well, you know, you need safety and you need to be able to get around, especially something this size. The interesting part has been watching the combiner design and watching how they tweak every single corner. There is not a sharp edge in that thing because, well, we all know RF doesn't like corners and likes to jump off them.
Mhm.
And so everything, a lot of it has been totally electronically designed and modeled and tested before it ever even got put onto metalwork. And it's amazing, you know, how they can simulate where the RF, where the corona will happen before it even gets power.
Hey, I just noticed Chris Tobin may be with us now. Chris, are you there?
I am here. Can you hear me? Am I coming through? Look
Absolutely.
at that.
Okay.
So you know, I'm not. This is not an undisclosed location. Okay, familiar name. I'm.
Good
By the
deal.
way, I'm
So-
at a place. I'm at a place that nothing here will go boom at the moment. Jeff knows that.
Somebody's heard my NUG report before.
2 years. Yeah. Well, last year was the last year was the boom. This year was just, well, we'll talk about it. Those of you who remember it, that's good. So you know, your Jeff's presentations are probably the best technical presentations I've had a chance to attend in a long time. They're very practical.
They are. They are awesome.
They are. And by the way, he doesn't stand at the podium.
Non-commercial.
He goes wireless. Yeah.
Ah.
He goes wireless for
Good
a
deal.
reason. That's all I want to say.
Okay. We had Jeff speak to our. I'm sorry. We apparently have a lot of delay here. Go ahead, Jeff. Go ahead.
I say they threaten to glue my feet to the floor every year. So far, they haven't found glue that'll hold.
No, that
That's
doesn't
good.
work. If that's Chuck Kelly, I'll call Chuck. No. You keep to your plan. It works very well. Trust me. It's good.
All right. We were just about to move to the subject of the 400 kilowatt AM transmitter. So, Jeff, you had some kind of a hands-on training up at Nautel recently, and some engineers got to lay their hands on 400 kilowatts. Tell me and Chris about that.
Well, every year after NAB, we do in-house training. We just basically, it's a 3 days of intensive, everything we can think to cram into 3 days of training. We cover AM on one day, FM on another day, and of course, where we're transmitter oriented, we're not covering mic to antenna, so it's quite a bit more restricted. This year for the AM training, I did it on one of the 400 kilowatts. Now, I will confess that I powered it on in test just to prove it actually worked, but I didn't make 400 kilowatts with the customers there. It's a 750 kVA entrance, and there's some arc flash issues that we don't necessarily have the training to handle, especially with customers in front of us. So we played mostly with the user interface, which is really cool to be able to stand there and this is a 400 kilowatt transmitter. This button makes lots of things happen, and then the noise level goes up, which is why my voice is an octave lower than it usually is right about now. But yeah, and I mean, we're talking a 400 kilowatt transmitter. Let's see, Kirk, you worked at WCRV in Memphis, that 50 kilowatt there.
Yeah.
That 50 kilowatt was 14 feet across by almost 4 feet deep and roughly 6 feet tall. We're doing 400 kilowatts in about 12 feet across and 3.5 feet deep now.
Wow. So much more compact. Ooh,
much.
That's a lot. That's a lot of power.
It does have an outboard power supply. The outboard power supply is roughly 6 by 6 by 6. It's a big vault. Well, as I say, it's a 750 kVA entrance for one transmitter.
Wow.
Now,
wow.
And if you're running DRM with peak modulation on, it will put out an instantaneous power of about 2 megawatts per 400 kilowatt unit.
Whoa.
Yeah, there's the eyebrows going up. So DRM,
when you have
DRM's the way to go.
When you combine 5 of these things together to give you a 2 megawatt transmitter, how do you synchronize these 5 transmitters in terms of audio and RF? How does that work?
Again, the cool thing is these days, it's like you said earlier, it's we were talking about the different technologies and the ups and the downs. And it's awesome that we can do it. It's mostly done with the fact that we're microprocessor controlled, so we can synchronize all this stuff through clock circuitry, GPS or whatever. I mean, we don't even need to use GPS. They're all in the same room. So the primary controller on the combiner sends a clock pulse out to all transmitters. We phase orient the wiring to make sure it gets to each one at the same time, and we're good to go. We can do dynamic phase correction as required just by monitoring each incoming signal and adjusting the delay on the clock in order to correctly time them so they all get to the combiner at the same time. It's not a lot different than what we've been doing for years with combined signals. We've done it, Kintronic has done it, I'm sure. I know Gates Air has done it back in the Harris days. So it's not really a new technology. The only thing that really changed is the implementation. Instead of having a central crystal oscillator with phase correction networks going to each transmitter and manually have to continually tweak them, now it's all dynamic and it just corrects itself.
Wow. And because I thought your answer was going to be you had a central oscillator. And well, I guess GPS kind of is that, but wow, that they're all dynamic and can be controlled in real time. That's like, to me, that's kind of like 5 kids on a 5-legged teeter-totter, you know, all leaning forward or backward to correct their individual, you know, moment on their teeter-totter. Wow.
And the really funny thing about it is when you look at the component count, it's a fraction of what it would have been for one of the older systems. And it's so much more stable. I mean, because there's no tweaking involved at all. And with a microcontroller, your parts count goes down such a huge amount. So your failure rate, theoretically, I emphasize theoretically, goes down as well.
Well, you may only have one processor on a board, but that processor, you know, could have 1 million transistors on it.
Right.
Yeah.
So, I mean, absolutely, it's doing the job of a whole bunch of pieces. There's no question about that.
Yeah.
But it's astounding. I mean, it amazes me every time I walk down there and take a look at that stuff. It's like, and the size it is. I mean, we built we built a 150 kilowatt 1 million years ago when I worked in our service department. And I got to do the install on it. That 150 kilowatt took up about the same space that this 2 megawatts going to take up. So it's just astounding.
So we have one more subject to talk about on the show today, and this is where I really want Chris to get involved in the conversation. I'm going to set it up, and then I'm going to back out and let you two talk about it, because my interest in this subject is because of my own experience with Nautel transmitters. Now, I dealt with a couple of them a long time ago, and any problems I had with them tended to be little mechanical things like cinch Jones connectors on the back of some modules, and I don't know if, or don't think you guys are using those anymore, but I rarely had a real electronic problem. And so I've always had this.
Going to say, you're talking to the guy that remembers these things. We troubleshot a failed power supply transistor on the 50 kilowatt once about 20 years ago.
Oh, we did? Okay, well, okay. You remember that? Holy cow. Well, we had a whole bank of capacitors burn up, but I wasn't going to go into that. But so now at my stations, I've got a couple of Nautel FM transmitters, maybe 2 or maybe 3 of them anyway. And I've had a couple of FM amplifier pallets fail. And your support department, you know, they were in warranty. Your support guys, got us a new pallet out right away. But then I had to, wrap my brain around the fact that I was going to have to undo a bunch of screws and get a soldering iron out. In fact, I had to go buy. I didn't bring a soldering iron with me because why would I? It's an Nautel. So I had to run down to the Walmart store where I bought a gas-powered, a butane gas-powered soldering iron, which worked a treat actually, and had to replace this pallet. And so here's what I want to get at. In today's world, where I think we have a lot less interaction between engineers and component or even board level stuff. I know I have a lot less of it. A lot more of my world, a whole lot more of my world, is dealing with IP addresses and VPNs and configuring stuff with a keyboard. And so and maybe replacing a fan, stuff that's going to get dirty and go out. Right. But I had to actually, do something I hadn't done in a while, and that's pull a transmitter out, flip it over, undo a bunch of screws, and replace some stuff that required solder. I videotaped it. I put that on YouTube because I was interested in that. So what I want to get at, what I'd like you two to talk about is think about the mindset and the preparedness that engineers who are maybe like me, just less frequent am I fixing stuff lately, okay, for the past few years than I used to. What do I need to have on hand? What kind of basic tools? What kind of special tools? And what kind of, how do I need to be mentally prepared to deal with stuff that I haven't soldered and unsoldered stuff in a long time? Now, when I got done, it all worked. It was great. And I really appreciate the support. But yeah, how do engineers, especially occasional engineers, need to be ready to fix a problem?
And that's kind of an interesting question. The VS, the low power, are the only ones that you actually have to solder. If you've got a higher power rig, you could swap out the whole module. It costs a lot more money. So, I mean, 15 minutes with a soldering iron, you spend more time taking the cover off and cursing at us for the 20 million screws we hold the cover down with. But on the other hand, it gives good RF shielding, so it's a trade-off. There are a lot of things you really need to have. I mean, number one, you need a good Phillips screwdriver, because if you strip one of those countersunk cover screws, you're going to call me up, call me names, and neither of us want to go through that. So having good quality tools has always been important, and it's just as important now as it ever was. Certainly, if you're like me and like to do things a little more economically, you're going to replace a failed amplifier pallet for $300 or $400 than you are going to swap out an entire module for several thousand. I mean, that to me is a no-brainer. So yeah, you do need a soldering iron. I think I counted them yesterday. I think it was 4 or 5 wires that had to be. You heat them and lift them off the pad, and then take the old one off and put the new one on, heat them, and solder them back down again.
Chris Tobin, you want to talk to us about your experience? I'm guessing you're doing less soldering now than you were 10 years ago, or when you were really visiting a lot of transmitter sites and doing studio repairs.
Well, I'm still doing a lot of transmitter work. That's one of the reasons I'm actually at this location doing some satellite stuff. So Jeff's right, though. You do the pallet change out. It's real easy. I have to say my experience with Nautel products going back to the AMFET days I remember helping Greater Media install a 25 kilowatt AMFET, one of the first solid state rigs, the AM rigs. And we did very little work with that. And fast forward to today, I've had to do very little work on any of my Nautels. The occasional SBC swap out, the small board computer, didn't require any soldering or desoldering. I've been very fortunate, but I do know friends who have worked on some Nautel rigs, and the screwdriver is important. You're right. There's a lot of screws, but I understand the reason behind that. So I get that. I'm not going to curse you out. I totally appreciate it, the RF. And then the soldering is straightforward. Have a good soldering iron, a good soldering station. Make sure you understand the proper way to tin soldering gun, or a soldering stick, that is. And that's it. If you're talking Nautel, and I can say from personal experience and working with a company that does a lot of service work for broadcasters, for both radio, FM and AM, very little needs to be done with expensive, crazy tools. It's more about safety. Make sure you're not the only one at the transmitter site. Make sure you've locked out the breaker panel. Let's see what else. Make sure you do all the safety points as mentioned in the NUG session at NAB on several occasions.
I'm glad he was listening. I do this.
I should leave the key. You could leave the key in the lockout, though.
If you're the only guy on the site, I've been beating the safety drum for several years, because it's something we take very seriously, and something that is just, it's easy to forget, especially when you're working a day job and doing contract work at night, or doing transmitter site work at night. And it's so easy to forget the simple little things. And it's like I did this during this training course this week, a safety presentation. And one of the things I said was, it's not always the voltage or the high voltage AC or RF you've got to worry about. I mean, if you're the only guy on the site on top of a mountain, and you walk around behind the transmitter and trip on a piece of Schedule 90 pipe laying on the floor and bang your head against a rack cabinet, what's going to happen? And it's funny, because one of my customers told the same story about a guy who had a heart attack or had heart problems. And if he had been at the site at the time, he would have been alone. He would have been out of luck. But he he was just fortunate at the time. He was in the studio and they heard him make noise when he went down. So it's something that we really should pay a lot more attention to than we do. And I know I've started to focus on it more at home. I won't tell the stories. Oh, I'm getting a glare from the other room. So somebody may have some comments about my own safety concerns. But it is something that I do pay a little more attention to than I used to. Several years ago, I tried to trim some branches off a tree with a chainsaw and a ladder in an orientation that a chainsaw and a ladder should never be used in. And I promise I learned from that mistake. I'll never do it again. And fortunately didn't land on the chainsaw.
This is true. Yeah. This is true. I worked at a site. I worked at a site where one year, I'll never forget this. We had 4 transmitters. One of them was an old General Electric AM with the fluorescent light bulbs in the front. It was glass front. It was a classic 1950s Art Deco appearing box. And we're working with the gentleman, and he walks in. He goes, "Oh, what are these?" I said, "They're transmitters." He wasn't an engineering person. He was a production person. He was just out there to be my second set of eyes. I said, "Whatever you do, don't touch anything. Just stand near the phone. I'm going to work on this I just took the job. The place was in disarray. Doors off on the transmitter. The cutout switches, the lockout switches bypassed, you name it. It was a mess. And a broom handle being used to hold the prop open, prop on the plate current circuit breaker. So to give you an idea. So if you could picture the front of a Collins transmitter and the plate breaker with a broom handle holding it open so it wouldn't trip, give you an idea of the condition of the place. So I tell him, don't touch anything. Just stand by the door. You'll be fine. I'm working around, checking stuff, looking inside a transmitter with one hand behind my back and the other hand, so if I fall, I don't make a circuit close the circuit, old-fashioned way of doing things. And all of a sudden, I hear this pop. Yeah, the typical sound you hear when you open up a transmitter with the old-fashioned high-voltage switches that shorting switch. I look around, and there he is, pale white, shaking, and going, "I thought this was a file cabinet." I told you, it's a transmitter. Stay away from the gray box. So speaking to safety, it was great. It was a great sound. We all know the sound. It's like an FM. If you have a Havas transmitter, you kick on the old FM 25s. It was very loud contactors. It was just, I heard it. I'm going, oh no, what did he do? I look over and he was just totally, good thing he didn't soil his pants. We didn't have a puddle, but it was very close. It was real close. And he thought it was a file cabinet. I said to him, when was the last time you looked at a file cabinet that had a glass window on it? He goes, oh, good point. I'm like, oh, never mind. So yes, to Jeff's point, safety is very important. And I will say that I do some climbing. I do have a climbing harness, and I've done the training for the 100% tie-off. I don't climb 1,000-foot towers, but I do a lot of stuff around here in the city and other parts where I'm up a good portion. I've been on top of the Empire State Building, Time Warner Center, a few other places. So safety for me has been 100% everything. And Jeff is right. There's not enough stressed about it, and it's something we really should keep reminding ourselves. It's simple stuff. You don't have to get crazy, but just remember the simple stuff. As a friend of mine who's a TV transmitter maintenance contractor always told me, I'm looking inside an IoT transmitter. The thing I do is one hand behind the back. But I'm looking in just so I don't fall down and put both hands on that capacitor circuit or power supply. And it works. It helps. Oh, yeah. I'm sure Jeff's heard that story from people, or he may practice it himself. And also being a ham operator that I am, I do a lot of experimenting. So yeah, I have many things have gone boom when I've worked on them for fun. So.
Jeff and Chris, we're going to take a quick break, and perhaps we can come back with a quick tip of the week from each of you. Jeff, I'm sure you'll have a good tip for our listeners. And Chris, I know you always do too. You're watching or listening to This Week in Radio Tech, episode 347. Jeff Welton is our guest. He's from Nautel. Been talking about some great technologies there and white papers that were given there with best practices and new information too. Our show is brought to you in part by our friends at Lavo, L-A-W-O, Lavo. The website is lavo.com/TWiRT. And that way they'll know that you heard about it right here. Well, at the NAB show, Lavo introduced a new radio console called Ruby. It's called the Ruby Visual Radio Console. What does visual mean? Well, it's got some fantastic visual control in addition to the usual sliding faders and buttons to turn things on and off and assign program channels. It also has a beautiful visual control as well. You can load snapshots. You can control EQ and dynamics processing. And the controls are very intuitive. In fact, it uses a tool that Lavo has had for some years called VisTool, and enables you to design custom context-sensitive screens that suit your station's unique operating style. Well, in addition to the visual control and the new Surface, by the way, it does have motorized faders as standard. They give you this power core. That's the part that does all the mixing and control. And it's way over designed. It has actually a 4,000 signal capacity, massive amounts of DSP, and that enables perfect audio shaping with 96 channels of parametric EQ, expansion, compression, limiting, de-essing, and delay synchronization. You can mix to as many as 80 buses, and there's plenty of I/O. 2 Ethernet ports, each carry 64 AES67 inputs and outputs, plus there's 4 MADI ports, and those handle a total of 256 MADI signals. Flexible I/O options as well. You can outfit it with different I/O options on the back, including high-density DB25 connectors using the AES59 wiring standard, plus other options as well. The console is beautiful. It's a thin console, sits on the desk, but it's almost as low as a flush mount console. The new Ruby console from Lavo. If you want to check it out, go to the web page for the Ruby console. We'll put that in the show notes so that you can give one click to it, or go to Lavo, lawo.com/TWiRT, and then look for radio consoles and look for the Ruby. Once you're on that page, there's a video there. You can click right on it and find out more about the Lavo Ruby console. Again, just introduced. Senior Product Manager Axel Kern, I know Axel, he explains a couple of other features, the auto mix and the auto gain features that are built into Lavo radio consoles. Check it out, Lavo, lawo.com/TWiRT. Please put that on there. Give us a little bit of credit. Lets them know that you are a fan of the show. Appreciate it very, very much. And thanks to Lavo for sponsoring This Week in Radio Tech. All right, gentlemen, let's see if we can get a couple of quick tips in here. Chris Tobin, would you like to start with our tip of the week?
Sure. Tip of the week, I've been working on some Ubiquiti IP radios. I'm actually putting together a project for a friend, and realized that when we got to his facility, he plugged everything in. He said, "This is great." I was like, "What are the IP addresses?" "Oh, I don't know." "Great. And did you do static IP?" "No, I did DHCP." "Got it." Discovery tools. If you're working with equipment that offers discovery applications, use it. It's real handy. So I did it with that, and I was doing video IP, and P3 Tech product shipped DHCP turned on. So when you plug in and decoders, they're already DHCP. They have a discovery tool also. Works like a champ. And I've used that with some audio over IP codecs as well. I won't particular name brands. Don't panic. It's a good thing, and it's something you should be looking into. Discovery tools from a lot of manufacturers are very, very handy items to use.
Cool. All right. And Jeff Welton, do you have a tip for our listeners? Probably about Nautel consoles, but doesn't have to be.
You'd be wrong.
Sorry.
You'd be totally wrong. Not about Nautel transmitters at all. Actually, it's sort of on the safety theme that we were talking about. Is this little guy right here? I don't know if you've ever seen one. This is worth its weight in gold. It's a thermal imaging camera. It attaches. You can buy them for either Android or iOS. So it just plugs right into your regular old cell phone and gives you a complete thermal image. I'm going to see if I can haul one up real quick. I know you're running low on time, so we'll make it as fast as humanly possible. But the cool thing about it, I got this thing, and within, the day after I got it, I was at a transmitter site, and the very first thing I did when I walked into the site was to take a picture of the breaker panel on their wall. Let's see if I can get this in front of the camera. You see that top corner of that breaker panel? The little red bit?
Red spot.
Yeah.
Hot breaker. That's taken from about 6 feet away with the cover on the panel. So it gives you a really fast way of identifying hot spots. $250 US. I picked this one up more for safety demonstrations, but like I say, the first 24 hours I owned it, I'd already saved a station from a potential site fire. Absolutely, hands down, probably the coolest toy I've ever managed to acquire.
Wow, very cool. I like that. I see that model and some others online. Looking at Amazon, but that is very cool. We'll put some links to that in the show notes as well. I've always wanted one of those, and boy, they're almost affordable now. And of course, they're indispensable if you're responsible for the safety of the site.
Right. It's like I tell people, the camera's $250. It plugs into the phone you already have. What's a new transmitter site cost?
Yeah. Good point. Wow. Awesome. All right, gentlemen, thank you so much. And Jeff, if you'll send me a link by email to the one you're looking at. The ones I saw were more expensive, so you've found a better deal there. Please,
I will
let me know about it. All right, good. Hey, you've been watching This Week in Radio Tech, episode 347. Jeff Welton has been our guest. Chris Tobin has been along from ABC Radio Networks, apparently. Still don't know exactly where he is. Figure that out. And Chris, by the way, you got home from NAB okay? Everything good?
Oh, absolutely.
Still there?
No, I took the red eye.
Good.
I took the red eye. I had a good time. Yeah, it was good. Everything,
Yeah.
no incidents. I didn't get pulled out of my chair. Good. I wasn't told I had to get off the plane. Nothing. I'm good.
Those of you who watch my YouTube or Facebook channel, you know that right after NAB, I got to spend a couple of days with Joe Talbot of Telos, and we went out in the high desert, did a little drone flying. Although it was windy, it was too windy to get great pictures. But we also went to KNYE, the FM station in Pahrump, Nevada, and did a little video there of a transmitter installation, a little look around the tower from the drone. So that was fun. Jeff Welton, I guess you got home okay and went right to work with some education there at the factory.
I was home at 3 o'clock Sunday morning, 2 o'clock Sunday morning, I guess. And by sometime early Monday morning, I was in the office and standing in front of a 400 kilowatt transmitter. So that'd probably be the other reason I didn't turn it on. Get a little. So yeah, I'm looking forward to some downtime. I'm just not sure when it'll happen, and that's fine.
Yeah, I hear you. All right, thanks very much to Suncast, our producer for This Week in Radio Tech, and to Andrew Zarian, owner of the GFQ podcast network at gfqnetwork.com. Thanks to our sponsors, lavo.com/TWiRT, bswusa.com, and the Telos Alliance at telosalliance.com. I'm Kirk Harnack. I think next week, I believe, if I'm not mistaken, our guest is Joe Cipriano, famous voiceover actor, and he'll be talking about microphones, all about microphones and which ones work well for him and how he tells engineers just how to get it just right and just do it himself. We'll see you next week on This Week in Radio Tech. Bye-bye, everybody.